All right, let's carry on then with our section that we're working on, which is standard deviation from section 5.3. Sorry, I wanted to do it the opposite direction. Let's carry on with part 2. Where we had stopped before was we had finished an example where we were looking at standard deviation in the example of the basketball game. And so we want to carry on a little bit more just to kind of give you some information on some of the symbols that we use when we are calculating the standard deviation. One of the first ones that I put before you and wanted you to try and figure out what was going on was the following. As you know, this stands for the mean of data. So you can see that there's a new symbol in here that you've not seen before, this funny looking sort of zigzaggy kind of thing. And so the question was, what does it mean? Well, we know already that to calculate the mean or the average of something, we take all of the numbers involved in the data set and add them together and divide them by the number of numbers. So what this seems to tell us is that this stands for adding numbers up, a sequence of numbers, and that's exactly what it is. It's called summation notation. It talks about taking a group of numbers and adding them all together. So that will help you understand when you take a look at the actual formula for standard deviation. We've already seen that we use this Greek letter symbol to stand for, standard deviation. And then if you look at this, it may look a little bit like hieroglyphics, but you should be able to see where we started. So let's look on the inside. What we did was we found out how much all the information, deviated from the mean. So we took every piece of data and we subtracted the mean. And once we had all those numbers, we squared them all. And once we had all those numbers, we added them all together and divided them by the number of numbers so we could find the average of the square of the deviation. And then once we had that number, we took its square root. So this is just a fancy way of writing the formula that you followed through when you followed that table for that first example. So before you kind of lose your mind over this and think, oh my goodness, I'll never be able to understand what this is all about, let's just summarize. Standard deviation is a measure of dispersion, of how the data in a set is distributed. It's often used as a measure of consistency. How consistent is the data that we find in the set? When data is closely clustered around the mean, the process that was used to generate that data can be interpreted as consistent. And when the data is scattered far away from the mean, the process that was used to generate that data can be interpreted as less consistent. So let's try a couple more examples to help you understand what's happening. And so we're going to take a look at a situation where someone is examining bags of sunflower seeds. So let's look at it. Brendan works part-time in the canteen at his local community center. One of his tasks is to unload delivery trucks. He was curious about the accuracy of the mass measurements given on 2 cartons that contained sunflower seeds. He decided to measure the masses of the 20 bags in the 2 cartons. One carton contained smaller bags with 227 grams in them, and the other carton contained supposedly 454 grams. So what he did was take out all those bags and actually measured them. And here's what he found. These were the masses of the various ones. So at this point, if you're doing the video, I want you to stop and see if you can practice using your calculator to be able to find this, to find the range, mean, and standard deviation for each one of these bags, or cartons really is what it is. And eventually you should get the following values. That for both the different sizes, they had a range of 18, that the mean or the average value of the actual masses of these bags of sunflower seeds was the following. They're pretty close. This one was 227.15, 454.4, so they're pretty close to what they were. But what is interesting is the standard deviation. This one, the data actually is dispersed further from the mean than for this one. And so the question is, what would Brendan's conclusion be looking at something like this? Well, if he's looking at this data points, what he can conclude is that the mass of these larger bags of sunflower seeds was more consistent than it was for the smaller bags. That the smaller bags seem to have some kind of a glitch. That means that the actual weight inside these bags goes a little further away. So the question would be, how might this information be used by the company that sells the sunflower seeds? Well, if they're concerned with quality control, then they want to make sure that they're more consistent. Maybe they need to go back to taking a look at the machines that are preparing this 227-gram bags and make sure that there's not a glitch somewhere. Make sure they tighten it up so that they have a better quality control. Lastly, looked at a scenario where a person named Angel was taking a survey about the number of hours per week that grade 11 males in her school played video games. She determined that the mean was 12.84 hours with a standard deviation of 2.16. Janessa conducted a similar survey of grade 11 females in her school, and she organized her results in this frequency table. Compare the results of this group of females and this group of males. Now, what we have here is a little bit interesting. This is what we are using for a frequency table. And remember what this means, distribution table, that 7 of the people who were actually surveyed had a response of 3 to 5 hours. While if you jump around, 12 people had a response of 11 to 13. So remember, reading a frequency table is a little bit different. If we look at it and count at all the frequencies that we have, it adds up to 70. We have about 70 different survey results, but we do not know specifically what they were. They've been lumped into groups. So it's a little bit, when it comes to finding it and calculating it or putting it into your calculator, it's a little bit different. So when I did this one, I actually did put some notes on to help you with it. What happens when you're looking at one of these, and we did this earlier in another section, if you're calculating the mean of a frequency table like this one, we actually have to figure out what the middle is of each one of these. Since we don't know how many were low and how many were high, to get the best estimate we can, we choose the middle of each one of these frequencies. And so intervals, pardon me, each one of these intervals that were given. So we'll be using the midpoint as the number. Now, ordinarily, if we did it by hand, we'd say, okay, the middle's 4, so 4 times 7. So if I take the sum of all those guys, it's basically 28. While this one would be 6 times 11, and so on all the way down. So we're finding the sum of all our values, and then we divide them by the number of numbers, and that turns out to be 70. And we find a mean. Now, the problem is, how do I put that into the calculator so I can actually find the standard deviation? So just a quick note for you. In list number 1 in your calculator, you'll list all of the midpoint values. In list number 2, you're going to enter the frequency values. Then when you go to ask the calculator to calculate the one variable stats, you will write beside it the list where you've placed the midpoint first, so L1, comma, the list where you've put the frequencies, L2. And if you do that, the calculator understands what you're doing and actually will give you your data with no problem at all. And what you find is the following values. And, we took some time to look at the results of this particular survey that they had, and we could see that in this set of males and females, the males watched or played video games for a greater average of time than the females. And then when we looked at the standard deviation, we saw that the values for females deviated more than it did for males. So in this data set, these males were more consistent in the number of hours that they were watching, whereas for the females, it varied more in terms of what they actually watched. Okay, there you have it. That's the end of part 2, where we've been looking at the standard deviation, figuring out how to do it by hand and by calculator, and using it to help us interpret some data sets in real life examples. Good luck with your homework. Remember that the first part of your homework is just question number 1. Remember that on Monday, when we get back to class, you'll be working on this set of questions, which you will need to hand in to me as well. The reason we have to do this in class is that you need a calculator to be able to do it. And on that second day, which is the Monday, you'll be doing the following homework on your own. All right. So look forward to working with you. Have a good weekend, everyone.